Okay, so in this video we're looking at the SEC Leaving Cert 2016 Higher Level Maths Paper 2 Question 2, and it's coordinate geometry of the circle question with a little bit of line thrown in, obviously. A point X has coordinates minus 1, 6, and the slope of the line XC is 1/7. So that's this line here has a slope of 1/7. Find the equation of XC. Give your answer in AX plus BY plus C form, and A, B, and C are all integers. So you know you should get nice whole numbers or 0. Positive and negative whole numbers including 0. We know the slope and we know a point that is on XC. So we can go straight into using y minus y1 is equal to m by x minus x1. We know our slope m. Important with our x1 to be careful that it's minus 1, that we'll get a plus 1 when you sub that in. We're then going to get rid of the fraction, so multiply coming from this line to this line. Multiply both sides by 7. So multiplying the right-hand side by 7 just gets rid of the fraction. That's why we're multiplying by 7. And multiplying the left-hand side by 7, you have to multiply the 7 into the bracket as a whole. So that is why we get here 7 by y is 7y, 7 by minus 6 is minus 42. 1 by x is x, 1 by 1 is 1, and then we rearrange, so we want it as ax plus by plus c form. Really, look, very, very simple question to begin with. So quite nice to lead you in like that. Next part of the question is much longer. There's no point in trying to sugarcoat it. C is the center of a circle S of radius 5. Okay, we know the radius, so that's really important there. We can build towards this already. Remember, this is our formula for radius. G squared plus square root of g squared plus f squared minus c is equal to the radius. So there we have one equation already with 3 unknowns. Okay, I've squared both sides, and I've got one equation already with 3 unknowns. I just need to find g, f, and c. What else do I know? The line 3x plus 4y minus 21 is tangent to S. So this, the perpendicular distance between this line and the center, the perpendicular distance between that line and the center is the radius. As it's a tangent, the distance between the center minus g minus f and the radius must be equal to, the center and the tangent must be equal to the radius. The center and the tangent, the perpendicular distance between the center and the tangent must be equal to the radius. Anything else that we have? Yeah, we also know that the center minus g minus f satisfies xc. Remember, minus g minus f is actually on that line. We've found the equation of this line right here. It's something we just found. So minus g minus f should satisfy it. Look, I sub it in and I get an equation with 2 unknowns. I should know minus g minus f should work out like that. Okay, so I've got one equation here, brilliant. One equation here, brilliant. I need to get that third equation. Because I know I have 3 unknowns, G, F, and C, I must have 3 equations. So I split the page down the middle here. We're really dealing with the left-hand side here. So we're using the perpendicular distance formula. We know it's the perpendicular distance between the tangent. Make sure you're using the equation for the tangent. The A is 3, B is 4, and C is minus 21. X1 and Y1 is minus G minus F respectively. And I know the perpendicular distance should work out to be 5. Because that's the radius. So subbing everything in and starting to multiply it out a little bit, we get to this point and go, okay, well, what don't I like? I don't like the fraction. So I'm going to multiply both sides by 5, and that's where I'm getting to the 25. Now, if you look back at your equation 1, we could try and multiply this out, but it gets a bit nasty very, very quickly. It gets really nasty very, very quickly. So what I would recommend is go back and look at your equation 1. Remember, there was only 2 unknowns in it, in this equation 1. So you could isolate g very quickly to get down to that circle down there at the bottom. And if you can isolate g, then you could sub that in here. It's been subbed in. Now, in this equation right here, how many unknowns are there? There's only 1 unknown in that equation down there, meaning we can actually find it, we can solve it. Okay, so that's what I do all the way down to here. So I multiplied it out. Minus 3 by 7f is minus 21f. Minus 3 by 43 is minus 129. Minus 4f, minus 21, fine. Tidy it up a little bit. And then I want to get rid of the modulus signs. Okay, how do I get rid of the modulus signs? I square both sides. So I've squared both sides. Minus 25 by minus 25 is 625. Minus 25 by 150 by minus 25 is plus 7500f. And minus 150 by minus 150 is 22500, or 22,500. 25 by 25 is 625. Tidy it up, get down to here. You've got a quadratic equation. You can either use the minus b formula or divide everything by 625 to get down to something even nicer. And what links 35 and 12? We're going to use the guide number there to find two options for f. Two options for f. Fantastic. Okay, well, if I have f, what else can I go and do? I could also go back and try and find my g. Remember here from this, I have g on its own as long as I have f. So I have two options to deal with. I have f is equal to 1/7, or f is equal to minus 7, or f is equal to minus 5. So I'm using my two options for g. I'm putting in the minus 7 to get minus 6. And then I'm also going to sub in my minus 5 to get 8. So I have two options. I have the green option and I've got the yellow option. So I go and find c then. How do I find c? Well, I look at equation 2. Equation 2 was here. G, F, and C in it. So brilliant. I can go and rearrange it so I can get c on its own. And then I'm subbing in minus 7 and 6. Subbing in minus 7 and 6 to get c. And then I do the exact same, except I'm going to sub in minus 5 and 8 to get c. Minus 5 and 8 to get c. I'm getting the other value for c. Okay, so I have a yellow option and a green option. Here I finally finish it off with using the yellow option, I think it is. No, it's the green option, excuse me. Green option. And then yellow option over here, which was f is equal to minus 5, g is equal to 8, c is equal to 64. Sub it into the two equations and multiply it out. Admittedly, like, that's a very long question, but you do have 15 marks. It was 10 marks going for the first question and 15 marks going for the second question, so part B. So this question, that part B, should take you a good like 7.5 minutes. That's as long as the video is now, really, to get through it. Tough question, but doable with a bit of practice. I would highly recommend. I think it's a great question, to be honest. It tests your coordinate geometry of the circle very well. So I put a lot of effort into this question in particular. Hopefully you found the video useful anyways.